years ago, and we came out here and did some surveying just to see the spot. This was just a field, and so the idea Judy had was to reconstruct kind of something like Stonehenge. It's a nice teaching tool. You could build it. You don't have to have huge rocks to do this. You can build it with smaller ones. But from this center point, we're standing right here in this angle. That's due south, okay? And then over here is due north. And then what gets a little more interesting is that's due west. Now, the tricky thing here is that your horizon is rarely truly level. You know, you have hills or you have trees or things that are in the way. And you have to make a little bit of an adjustment, because what people like at Stonehenge did was they wanted to mark a gateway, like between these two rocks here, where the sun will set directly between those two rocks on the equinox. So on the first day of fall or the first day of spring. So September 21st or so and March 21st or so. So on that day, those 2 days and no other days of the year, you'll see the sun setting. Basically, if you get down low, you have to get down low here. If you're here on that day with a camera, you would see the sun setting right between those two rocks. And likewise here, you can't get low enough because of all the trees, but Judy set it up so that straight above that gateway is where the sun will be. Now the sun actually rises. If we cut down all those trees, we'd see that the sun rises a little bit to the left. You saw that in John's video today, that the sun isn't moving straight up from the horizon, it's actually moving at an angle. So if we were here on the equinox and watched it all day, the sun would rise there and actually appear above the trees, kind of centered on that gateway, continue on up in the sky, about a mile and at noon, and then swing back down. And so this path of the sun, this angled path of the sun, is the first thing that a lot of people don't realize. Most of my students say that if I ask them on a multiple choice quiz, they'll say the sun rises in the east every day, goes straight overhead, and it sets to the west. And then they, despite all the obvious things you see, going out in the winter and seeing all that. So that's the first thing to notice. It's got this angle. And what's the height of the sun at noon on the equinox?
43 degrees. 43-degree angle.
Okay, so we're up around
42.7 or something. Yeah.
Well, okay, so not exactly, because let's think about it. If we were at the North Pole at 90 degrees north, the sun would be right at the horizon all day on the equinox. In fact, you'd see half the sun. So it's kind of 90 minus. We're close enough to 45, and it's hard to remember which side we're on a bit. So it'd be about 47 degrees. Okay. So it'll be up the lake was, 47 degrees, and then 47 degrees. So nice arcing it. Now, let's take tonight. So we're very close to the summer solstice. So what is it today? It's just a week or so past. So the sun actually at the solstice moves very little. Changes its what we call declination, which is like a celestial latitude. Changes its declination very slowly. It's less than its own diameter. In fact, probably only about half of its diameter away from where it was a week ago. So it barely changes for a couple of weeks. That's why they call it solstice. Stis means stationary. And so the sun is stationary. It just seems to have moved up to the north and then just stay there for a while. And then it starts back on down south. So if we were here a week ago with the summer solstice sunrise, I believe just the peak of that rock is pretty much where the sun would rise.
The tall rock?
The tall rock there. Judy when she first built this, she had these smaller stones, you see, and then she was able to, through donations and things, able to get bigger rocks, which were brought in about 7 years ago, I think. And so you can look at that rock now, and that's where it would be on the solstice, rising. And tomorrow, if you came out tomorrow morning early, it's just about the same spot. You'd see, barely notice any difference. We'd come up here, and now it still comes up at that same angle. So Again, 90 minus your latitude, so it would be coming up at an angle from the horizon of about 47 degrees. It would come up here, about there, and now, okay, we have to add, we had 47 above the horizon before, add 23 and a half, the tilt of the Earth, so we're up to 70 degrees, so the upper's around 70 degrees high at noon, and then it would come back down and set over there at the summer solstice sunset. And you can kind of see that if I hold the umbrella here and look where that's going to hit the horizon, that looks about the right angle there. Okay, so you can, if you want to play with the umbrella in a minute, you're welcome to do that. You can see that angle coming down. So it really comes at a lot of big angles.
Big angle.
And then that's the shift from the equinox to the solstice. So it's marching along. Coming September 21st or so, the sun will be coming down and hitting there. And then as we go past September 21st, it will be rising to the south. So there, winter solstice sunrise. And now it's get up to 47 minus 23. Okay, and so now it's going to be 24 degrees or so above the horizon. So it's really low. You know, it's no higher than it is right now. It's maybe even a bit lower than it is right now. And so it'll only get up to there, and then it will set over there above the winter solstice sunset rock. Okay. Now that's the first piece of this. Okay, and so that's we know that